Now in this problem we're trying to find how much energy is required to run a 25 kilowatt ultrasound device for 30 seconds. So let's try to identify what we're given here. So we have 25 kilowatts. So if we try to look and see what the units for kilowatts are going to be, all right, now let's try to solve this problem. We're trying to find how much energy is required to run a 25 kilowatt ultrasound device for 30 seconds. So first thing, we have 25 kilowatts. So this is 25 kilo is 1,000, so we can write that as 10 to the 3 watts. So watts represents power. So we're given the power, and then the other one is 30 seconds, so that's going to be time. And we're trying to find the energy. So the basic equation for this one is power is going to equal work divided by time, but essentially here work is the same as energy. So we can just rewrite this as power equals the energy divided by time. So let's just use this one then. So we're trying to find the energy or the work. So if we multiply both sides by t, t's cancel here, and you get that the energy is going to be the power multiplied by the time. So the energy is going to equal the power, which is 25 kilo, so 10 to the 3, multiplied by the time, which is 30 seconds, and that should give you 7.5 times 10 to the 5 joules. In this one, we have a 4.9 kilowatt crane. It's used to lift a 300 kilogram box up to a height of 50 meters, and it does that in 60 seconds. How much force does the crane exert on the box in order to raise it up at a constant velocity? So let's just try to identify the variables first. So you have a 4.9 kilowatts, and again kilo means 1,000. So since this is a unit of watts, this means that this is power. And next we have 3,000 kilograms. Kilograms means that this is mass. And next we also have 60 seconds, and seconds implies that this is time. And we're trying to find the force on that crane. And it says that it's going upwards at a constant velocity. So let's try to draw a picture for this. So you have a box, and the box has a mass m, so gravity's pulling downwards on it with the force Fg, and the crane is lifting upwards with a force, and let's call that one the applied force, or the same as the lifting force. And that's what we're trying to find. So the basic equation then is going to be the power is going to equal the force applied multiplied by the height that the box is raised divided by time. And so let's just try to isolate the applied force. So this is going to be, since y is on the top, we'll divide by y on this side, and we'll divide by y on that side so that they cancel. And since t is on the bottom, we'll multiply this side by t and multiply that side by t so they cancel. And what you're left with is the power multiplied by time divided by the height is going to equal the applied force. And now we can plug in. So the power is 4.9 times 10 to the 3. The time to lift it is 60. And the height that it's raised is 50. And that should give you an applied force of 5,880 newtons.